Hello students, I am Dr. Sangeeta Sharma, your science teacher. Today we will be continuing with chapter 13 of your science book, that is magnetic effects of electric current. And in today's video, that is part 5, electric motor, we will be studying about electric motor. Students, in our previous video we have already studied that a current carrying conductor experiences a force when it is placed in a magnetic field. We will use this concept to understand the working of electric motor. So students, let's understand electric motor. Electric motor is basically a device which converts electrical energy into mechanical energy. So electric motor is a rotating device which converts electrical energy into mechanical energy. And the principle behind this electric motor is, students, that electric motor is based on the principle that a current carrying conductor placed perpendicular to the magnetic field experiences a force. Now students, here we have used the word perpendicular to the magnetic field because in our previous video we have already studied that the force experienced by a current carrying conductor placed in a magnetic field is maximum when it is placed perpendicular to the magnetic field. So we will use this concept here to understand the working of electric motor. So the principle behind the working of electric motor is that a current carrying conductor placed perpendicular to the magnetic field experiences a force, and we have already studied that the direction of this force can be calculated using the Fleming's left hand rule. So let's recall the Fleming's left hand rule. So students, if we stretch the thumb, the forefinger and the middle finger, or you can call it the central finger, and if we stretch all the three fingers perpendicular to each other, and if the forefinger points towards the magnetic field and the middle finger or the central finger points towards the direction of current, then the direction of the thumb gives us the direction of the force experienced by the current carrying conductor placed in the magnetic field. So students, we will use this Fleming's left hand rule to understand and to evaluate the direction of the force experienced. So students, to begin with, let's first understand the construction of this electric motor. That is, what are the parts used in the electric motor, and then we will understand the working of this electric motor. So students, for the construction, first we have a armature coil. It consists of a single loop of a insulated copper wire in the form of a rectangle. Now here students, I have shown the figure, and here you can see that there is a coil PQRS which is made up of copper which is insulated, and this coil is known as the armature coil. Here you can see this yellow colored armature coil, students. This is P, Q, R and S. So this is a coil which is named as armature coil. Then the next thing is the strong field magnet. The armature coil is placed between two pole pieces, north and south poles of a strong magnet. This magnet provides a strong magnetic field. Now here students, we have taken a strong magnet. Here you can see the north pole and here you can see the south pole. So the direction of magnetic field here is shown by this white arrow, and here we have written capital B, which indicates the direction of magnetic field. So here students, you can see that there is a strong magnet. North and south poles of this magnet are placed likewise, and this armature coil is placed in the strong magnetic field produced by these two poles, that is the north pole and the south pole. And the direction of magnetic field here you can see is from the north pole to the south pole. So students, here we have understood the armature coil PQRS and the strong magnetic field between the north and south poles of this permanent magnet. So students, The next part is the split ring type commutator. It consists of two halves R1 and R2 of a metallic ring. The two ends of the armature coil are connected to these two halves of the ring. Now what does this commutator do? The commutator reverses the direction of current in the armature coil. Now students, what we are studying is split ring type commutator. Now what is the function of this split ring type commutator? It reverses the direction of current in the armature coil. Now students, it consists of two halves R1 and R2 of a metallic ring. Here in the figure we can see, so here students you can see there are two rings R1 and R2. These two rings are the split rings R1 and R2, and these two split rings are responsible to ensure the change in current in this armature coil PQRS. So what is the function of these two rings, which are known as the split rings, which are denoted by R1 and R2? That they reverse the direction of current flowing through the armature coil. This we will understand when we will do the working of this electric motor. Then we have students the brushes. Now the two carbon brushes B1 and B2 are pressed against the commutator. These brushes act as the contacts between the commutator and the terminals of the battery. Now students, here in this figure we can see that we have two brushes B1 and B2. These are the brushes B1 and B2. Now these two brushes B1 and B2, here you can see B1 and B2. These two brushes, what they do is, these are carbon brushes which provide us a link between the armature coil and the split ring with the battery. So what we see is that these brushes are responsible for the contact of the armature coil with the battery, and the split rings, these split rings which are denoted by R1 and R2, they reverse the direction of current, and these brushes provide us a contact with the battery. And here you can see the battery, and here we have a key also attached to the circuit. And here you can see that these brushes B1 and B2, these two brushes are fixed. They do not move. When you will understand this when we will do the working of the electric motor. But here you can see that these B1 and B2, these are connected to the battery through the key. So these brushes B1 and B2 do not move, but the split rings, they move over this axle. These two split rings, these R1 and R2, what they do is that they move over this axle. This we will understand further. So students, then we have a battery. A battery is connected across the carbon brushes. This battery supplies the current to the armature coil, and here we have seen that we have a battery which supplies current to the armature coil. So here students, we have understood the various parts of an electric motor consisting of PQRS, a rectangular insulated copper wire which is known as the armature of the electric motor. Then we have a strong magnetic field whose north pole and south pole is shown in the figure, and here we see here these two magnets are producing field, and the direction of the field is from the north pole to the south pole. Then we have split rings. These split rings are shown by R1 and R2, and they act as commutator, reversing the direction of current in the armature coil. Then we have brushes which are attached to the battery, that is they provide us a contact between the battery and the armature coil. Then students, here we have a battery and we have a key. So this is basically the structure of the electric motor. Now these split rings, they will move over the axle. Here you can see the axle. So these split rings will move over the axle. Now let's understand the working of this electric motor. So students, the working in the first half rotation, here we will have two half rotations, and first we will study the first half rotation. Initially the armature is in a horizontal plane. R1 is in contact with B1 and R2 with B2. Here you can see this students, that here we will understand the working of this electric motor. Now here for is I have changed the diagram, and here I have again used, the diagram is changed but the parts of the electric motor are the same. Here we have the strong magnets north and south pole. Here we have indicated the north and south pole with red and blue color. Then we have this strong magnetic field which is from the north pole to the south pole. This I have shown with this capital B. Then we have this armature coil PQRS, the split rings R1 and R2, and the two brushes B1 and B2. Now let's understand that how is the working done. Now initially what happens is, students, that this armature coil is in a horizontal position. Now when it is in the horizontal position, then you can see that B1 is connected to R1 and B2 is connected to R2. So what we see is that the current flows from the positive end. So the direction of current here you can see that it is going to be like this. Here you can see, students, that the current is going to flow from the positive end of the battery. So it will move like this. Then through the contact of this brush B2 with the split ring R2, it will move in this arm. And what we see is that the direction of current in this arm SR is in upward direction. Then it moves like this, and in the arm QP it is in this downward direction. So here what we see is that the current flows in the armature coil anti-clockwise. Here you can see this, students, that the current is flowing anti-clockwise. Now students, the direction of magnetic field is in this direction. Here you can see I have shown the direction of the magnetic field. It is from north to south pole, and the direction of current here it is shown that it is from S to R, and here the direction of current is shown from Q to P. Then using the Fleming's left hand rule, we can calculate or we can assess the direction of the force. Now let's see the direction of the force. Now students, in order to calculate the directions of the forces, I need to use the Fleming's left hand rule. And what I see is, students, that if I see it for this arm QP, then this finger is going to show the direction of magnetic field, this finger will show the direction of, current, then the direction of thumb will show us the direction of force experienced. Right, students? Now I'll explain you this for PQ. Here you can see that the current is flowing from Q to P. Now students, look like this. The direction of magnetic field is like this. The current is flowing from Q to P. Then the direction of force is upwards. Similarly, if you see it for the other arm is, students, this SR arm, and what we see is that in this SR arm the direction of current is upwards. So if I stretch my fingers like this, now the magnetic field has to be in this direction only, but the current is now like this. So what happens is, this shows the direction of magnetic field, the central finger shows the direction of current. Then what we see is that the direction of thumb is downwards. So the force experienced by RS arm is downwards, and the force experienced by this QP arm is upwards. So what we see is, students, that this arm experiences a downward force and this arm experiences a upward force. So this rectangular coil will move in a clockwise direction. So the armature coil will move in a clockwise direction. This is what happens in the first half of rotation of this armature coil. So students, here what we have seen is that initially the armature is in a horizontal plane. R1 is in contact with B1 and R2 is in contact with B2. When the current flows in the armature, the force acting on SR is vertically downwards, and the force acting on QP is vertically upwards. So what we see is the direction of these forces have been found by Fleming's left hand rule. These forces rotate the armature in clockwise direction. Here we have seen this, that the armature coil, due to these two forces, equal and opposite forces, the armature coil rotates in clockwise direction. Now this was the case when we had the first half rotation. Now let's see what happens in the next half rotation. Now students, in the next half rotation, after half rotation, students, if this is the armature coil, now it has rotated half. So again it is in the horizontal position. Initially it was like this, now it is like this. So here the half turn has been completed, but again the armature coil is in the horizontal position. So after half rotation of the armature, the plane of the armature again becomes horizontal. Now students, R1 comes in contact with B2 and R2 comes in contact with B1. Now here you have seen that now this PQ arm has rotated and it has come on this side, and the RS arm has rotated and it has come on this side. So what we see is that now the brush B1 is in contact with R2, B1 is in contact with R2 and B2 is in contact with R1. Since these split rings have moved over the axle, these brushes are fixed here. These brushes are not moving, the brushes are fixed. Now what has happened is that the split ring has moved over the axle. So this part, this PQ part which was on that side has come on this side, and this RS part which was already on this side has come on that side. बच्चों यहाँ पर क्या हो रहा है, यहाँ पर ब्रशेस जो हैं, जो कि बैटरी के साथ कनेक्टेड हैं, ये मूव नहीं करते हैं. मूव कौन करती है? ये स्प्लिट रिंग्स. तो ये जो स्प्लिट रिंग्स है ना स्टूडेंट्स, R1 और R2, तो R1 और R2 स्प्लिट रिंग्स जो हैं ये इन आर्म्स के साथ में मूव करती है. तो PQ के साथ में तो जुड़ी हुई है R1 स्प्लिट रिंग और RS के साथ में जुड़ी हुई है R2 स्प्लिट रिंग. तो जब ये PQ आर्म फ्लिप होकर और इस तरफ आ गया और RS आर्म उस तरफ चला गया, तो इनके साथ में ये स्प्लिट रिंग भी चेंज हो गई. अब ब्रश तो वहीं पर था, तो अब क्या होता है कि R2 जो कनेक्ट हो गया नेगेटिव टर्मिनल के साथ और जो R1 है वो कनेक्ट हो गया पॉजिटिव टर्मिनल के साथ. अब बैटरी जो है उसमें से तो करंट इसी डायरेक्शन में जाएगा. तो अब हम यहां पे क्या देखते हैं, करंट इस तरीके से आएगा, इस ब्रश में से इस आर्म में चला जाएगा. तो PQ के अंदर करंट अब किस डायरेक्शन में? फ्रॉम P टू Q. पहले किस डायरेक्शन में था? Q टू P. अब डायरेक्शन क्या चेंज हो गई स्टूडेंट्स? P टू Q. और इस आर्म में जहां पर पहले करंट S टू R था, अब करंट कहां है? R टू S. तो इस कॉइल के अंदर अभी भी करंट जो है वो एंटी क्लॉकवाइज डायरेक्शन के अंदर है. तो स्टूडेंट्स, ये जो स्प्लिट रिंग्स है जो कम्यूटेटर की तरह काम करती हैं, इनका काम ही है करंट की डायरेक्शन को रिवर्स करना आर्मेचर कॉइल में. तो यहां पर हमने क्या देखा स्टूडेंट्स? देखिए पिछले डायग्राम के अंदर आप देखिए कि PQ आर्म जो था वो उस तरफ था और RS आर्म जो है वो इस तरफ था. तो RS आर्म जो है उसमें तो पहले करंट जा रहा था S टू R और इसमें आ रहा था करंट Q टू P. और अब आप देखिए यहां पे करंट जो है वो जा रहा है R टू S और इसमें करंट जा रहा है P टू Q. समझ में आ रहा है स्टूडेंट्स? तो यहां पर हमने क्या देखा कि आर्मेचर कॉइल के अंदर तो डायरेक्शन करंट की जो है अभी भी क्या है? अभी भी एंटी क्लॉकवाइज है. तो जो हम फोर्स की डायरेक्शन निकालेंगे स्टूडेंट्स, क्योंकि करंट की डायरेक्शन पहले भी ऊपर ही थी, मैग्नेटिक फील्ड की डायरेक्शन भी इसी तरीके से थी, तो हम क्या ऑब्जर्व करते हैं कि यहां पर फोर्स की डायरेक्शन पहले की तरह नीचे होगी और यहां पर फोर्स की डायरेक्शन पहले की तरह ऊपर की ओर होगी. तो नाउ व्हाट विल हैपन स्टूडेंट्स? द अगेन दिस आर्मेचर कॉइल विल कंटिन्यू टू रोटेट इन clockwise direction. So what we see is that the current flows in anti-clockwise direction so as to produce a force such that the armature coil moves in a clockwise direction. So in the first half also the armature coil moved in the clockwise direction, and in the second half also the armature coil is moving in the clockwise direction. So the armature coil keeps on rotating in clockwise direction. So here students, this ensure current flowing anti-clockwise in the armature coil. This we have seen that in the armature coil the current is flowing in the anti-clockwise direction, right students? Then The force on RS is vertically upwards and on PQ is vertically downwards according to Fleming's left hand rule. So what we see is that here in RS it is vertically upwards and in PQ it is vertically downwards. So therefore the armature remains moving in the clockwise direction. Thus, the role of commutator ensures the rotation of the armature in clockwise direction throughout. तो बच्चों यहाँ पर क्या हो रहा है कि जो स्प्लिट रिंग्स हैं वो क्या करती हैं, वो एक्सेल के ऊपर रोटेट करती हैं आर्मेचर कॉइल के साथ में. तो आर्मेचर कॉइल के अंदर रोटेशन, दोनों ही रोटेशंस के केस में एंटी क्लॉकवाइज डायरेक्शन के अंदर करंट फ्लो करता है, जिसके कारण आर्मेचर कॉइल जो है वो हमेशा क्लॉकवाइज डायरेक्शन में मूव करती है. तो ये कौन इंश्योर करता है? ये इंश्योर करती है हमारी स्प्लिट रिंग्स जो कि कम्यूटेटर हैं. सो स्टूडेंट्स, नाउ लेट्स सी how the power of this electric motor can be increased. So students, the power of an electric motor can be increased by one or all of the following means. Now, by increasing the number of turns in the coil, what happens is, if we increase the number of turns in the coil, then the power of the electric motor can be increased. Moreover, by increasing the area of cross section of the coil, also the power of the electric motor can be increased. Students, by increasing the strength of magnetic field, by increasing the magnitude of the current flowing through the coil, by laminating the soft iron core, or by winding a large number of coils on the same soft iron core, the power of the electric motor can be increased. So what we see is that more the electric power of the electric motor, it will work more efficiently. So we can use these all 6 ways to increase the power of the electric motor. Now students, the uses of this DC motor. These are used in electric fans, which can be the exhaust fans, the ceiling fans or the table fans, for cooling and ventilation. These are used for pumping water. Big DC motors are used for running tram cars, and small DC motors are used in various टॉयज. तो बच्चों, आपने बचपन में जिन खिलौनों से खेला होगा या आज भी खेलते होंगे, उनके अंदर एक छोटी सी इलेक्ट्रिक मोटर लगी हुई होती है. उस मोटर के क्या पार्ट्स होते हैं और वो किस तरीके से वर्क करती है, ये हमने हमारे आज के वीडियो में सीखा. और उसकी पावर को हम कैसे इंक्रीज कर सकते हैं और उसके यूजेस क्या हैं. नाउ स्टूडेंट्स, वी हैव अंडरस्टूड अबाउट इलेक्ट्रिक मोटर्स. नाउ वी आर रेडी टू सॉल्व द प्रॉब्लम्स विच आर गिवन just after this topic. So let's solve these in text exercises. The first question is, students, that state Fleming's left hand rule. And today we recall this Fleming's left hand rule and we used it also to calculate the direction. And what we know is, students, that if the forefinger is pointing towards the magnetic field and the central finger or the middle finger is pointing towards the current in the current carrying conductor, then the direction of force will be given by the direction of the thumb. And here students, keep in mind that we have to stretch the fingers of the left hand and they must be mutually perpendicular to each other. So we will write the answer like this, students, that stretch the forefinger, central finger and the thumb of your left hand mutually perpendicular to each other. If the forefinger indicates the direction of magnetic field, north to south, and the central finger indicates the direction of current, plus to minus, then the thumb gives the direction of the force acting on the conductor. So this is the Fleming's left hand rule. Now students, let's see the next question. What is the principle of an electric motor? Today we have done the principle of an electric motor. So students, we will write the answer like this. An electric motor is based on the principle that a current carrying conductor placed perpendicular to the magnetic field experiences a force, and this we have used in the electric motor as the principle of electric motor. Now there is one more problem. Let's see what it is. What is the role of the split ring in an electric motor? Here we have seen this during the working of the इलेक्ट्रिक मोटर, that what role does this split ring play? हाँ बच्चों, split ring क्या करता है? split ring करंट की डायरेक्शन को रिवर्स करने के काम में आता है. तो हम आंसर को इस तरीके से लिखेंगे. द स्प्लिट रिंग इन द इलेक्ट्रिक मोटर एक्ट्स एज अ कम्यूटेटर. The commutator reverses the direction of current in the armature coil after each half rotation. Due to this reversal of the current, the coil continues to rotate in the same direction, that is the clockwise direction. So students, today we have done the electric motor. We have understood the principle, we have understood the working, and then we use the Fleming's left hand rule also here, and we have done the problems based on this topic, students. And we know that electric motor is a rotating device that converts electrical energy into mechanical energy. So students, in our next video we will learn about electromagnetic induction. Till then, stay safe, stay healthy. Bye.